Hey everyone, so today I'm going to be showing you how in Keras, when you're training a model such as a neural network, when you're looking at the training loss, Keras can actually show you a different number than what you'd be expecting or what your model is actually achieving, which can sort of, if you're relying on that to sort of evaluate your model, it can sort of throw your results off a bit. So I'm just going to show you how that works. Now, the way I discovered this was I was training a model, and I was sort of doing the graph, which I'm sure most of you have seen. This usual graph that you do sort of at the end of a model train, just to sort of see how the model's loss has reduced over time. For those who aren't familiar with it, basically it's each time the model is trained, the Keras calculates the loss for the training and the validation sets, and ideally we want those lines to be on top of each other. And like we can see here, the lines are on top of each other, which kind of indicates that there's no overfitting present. So so far it looks pretty good. If we have a look at the loss, I've just printed it down there. So you've got the training loss, which I've just highlighted in yellow. So we've got 0.33, and the validation loss as well, which is 0.334. So they're 0.002 difference, which is pretty good. So to me, that says that there's no overfitting. We're achieving the same loss in both the training and validation. So what's the problem? Well, if we calculate the loss ourselves, so Keras has done it and everything, but now let's calculate it ourselves. I won't go into the maths. It can be a little bit intense and sort of a bit daunting at first, so I won't go into it. But basically, I'm using binary cross entropy because the model that I was building was predicting a binary class, like yes or no, 1 or 0. So pretty much all you have to do is for every row, so you've got your data set, you've got the predictions, and you've also got the actual labels. You calculate the entropy, which you can have a look on Wikipedia. There's an entropy formula. So once you've got that for every single row, then you simply just get the mean of that entropy and times by -1. That's all you have to do. So I'll give you a link to this code so that you can have a play with it yourself. But basically, what I've got here is I've just made a new column called entropy, and then this is the formula in Python format. So it's essentially just sort of timesing the actual label by the log of your prediction and things like that. Anyway, we don't need to go into the maths. That is there for you. So we've calculated the entropy for every single row. Then all we simply do is, which as you can see here, entropy times mean. The mean of the entropy times -1. That's all we're doing. I'm doing it twice, so I'm doing it where my train test splits. That's just my training flag. So when that is equal to val or validation, give me what the score is, and when it's equal to train, give me what the score is. That's essentially what Keras is doing when you sort of see it at the very top there. So when I do that, you'll see the validation loss, we get 0.334, which up here, that's what we get, 0.334 for the validation. So the validation is spot on. If we look at the training, 0.31, but up here we got 0.336, so that's almost 3 percentage points off, which it doesn't sound a lot, but if we go back to our plot, which was just here, 0.31, which is what I'm getting, is not even on this graph. 0.31 is way down here, which if your training line is that far below your validation line, that's overfitting, definitely. So in its current form right now, my model is actually overfitting. But when I look at this graph, it's not. So what's the problem? If we go back, so yeah, why is it different? So I stumbled across, there's this tiny little section on the Keras website under the frequently asked questions, under this other bit, which is basically, why is my training loss much higher than my testing loss? There's various sort of reasons they give, and all these different things which can sort of throw the number off slightly. I won't go into those because they're quite specific and they're not sort of the main driver. The main driver, which is sort of altering and why we're getting different answers, is this bit I've highlighted in yellow. Now, it's a bit wordy, so just bear with me. But basically what it's saying is it's the training loss, which that's where we're seeing the problem. The training loss that Keras displays is the average of the losses for each batch of training data over the current epoch. So if you recall, we set our model to train over n epochs, so that's basically n full runs of the data, and for each run of the data, we break the data up into batches. So I've just got an example here. So let's say we're on our very last epoch, and we split the data up into 12 batches. So we feed in batch 1, so we break it up into batches so it's not to overwhelm the model. So we feed in batch 1, which gets a loss of 0.37. We feed in batch 2, which gets a loss of 0.37. This is just dummy data. So it keeps on going on. Naturally, as we feed in more data, you expect the loss to decrease and the model to be performing better. So, which is what's happening. 37, 36, it's going down to 33, where we're going really good, 31, 31. And when it finishes, it's down to here. It's on 31. The model is achieving a loss of 0.31. But remember, the model is with the training loss that we're showing is the mean of all of these. Which, when we get the mean, it's actually 0.336. That's that number that Keras was saying. It was saying no, it's 0.336. The number I'm getting is 0.31. So this explains the discrepancy here. So what's happening is, naturally, as the model sees more data, it gets better. So at the very start, when we feed in the first batch, naturally that's sort of going to be, we'd assume, is going to be the worst performing, because as it sees more, it gets better. So these higher numbers are actually sort of inflating this mean. And if we just go back to the Keras, so that's what Keras is actually saying. So, because your model is changing over time, the loss over the first batches of an epoch is generally higher than over the last few batches. So, yeah, when we're looking at this graph, just keep in mind that what you see here isn't exactly what you're getting. It's a great graph to sort of see, are we in the ballpark, and overall are things reducing and sort of reducing together. So don't disregard this graph, but just don't rely on it solely. So just some sort of closing remarks on that as well. So yeah, just use the plot above as a guide, and manually calculate your loss. There's formulas for all of the different losses. The one I've been using is binary cross entropy, which I'll give you a link in the description to my GitHub, which has those. And make sure you use other validations, which I'm sure you all do. So your ROC and that it's AUC, as well as a cumulative gains chart, and there's various other validations you can use depending on the problem you're working on. So yeah, that's pretty much it. Now, yeah, this is a new channel for me, so I'd really appreciate it, yeah, if you could subscribe. I don't want to be one of those YouTubers that constantly bang on about subscribing, but currently I've got 1 subscriber, it's my mum, so yeah, any others would be greatly appreciated. So yeah, thanks a lot for watching, and yeah, hopefully this was some help to you.